this was y equals 2 to the x, and this one is x equals 2 to the y, but the big question is, how do you solve for y when y is the exponent? How can you solve for y? You can't, can you? You can't. There's nothing we've had so far that would allow you to solve for y. So what we do in mathematics, when we don't know how to do something, we make up a definition. And this is what John Napier did back 400 years ago. He said, let's take this x equals 2 to the y, and let's make a definition like this. Y equals log base 2 of x. Now that looks like a foreign language, doesn't it? You've probably never seen anything like that before. If this is the first time you've ever seen logarithms, I know it's the first time you've ever seen that. But what this means, the way this logarithm is defined to be 2 to the y equals x. So this is what we call logarithmic form. Logarithmic form. And this is what we call exponential form. Let me give you a numerical example. Suppose we have, and I think I'd like to use as my example here from my chapter 4, section 4.01. Number 2, problem number 2 says to find the log base 3 of 9. Log base 3 of 9. Now how in the world would you find a logarithm? You don't even know what a logarithm is. All I've given you is one very simple definition. It may not look simple the first time you're seeing this, but it is simple. What this means is 2 to the y equals x. Okay, we need to get this pattern down. So write that down a couple of times. Y equals log base 2 of x means 2 to the y equals x. 2 to the y equals x. Now let's take this problem and say we don't know what that is, so we'll let it equal what? Some unknown number? Let's say x. Let this be x. Let this be the x in this case. Now, can you translate this for me into exponential notation? What does that mean? Take the base number here. The base number of the logarithm is the base number of the exponential notation, which says what? 3 to the x equals 9. 3 to the x equals 9. Start with the base number, go across the equal sign, and then bounce back. 3 to the x equals 9. Write that down. 3 to the x equals 9. And then ask yourself, what is x? X is 2, isn't it? X is 2. So x equals 2. This x equals 2. So what we're saying when we take log base 3 of 9, we're saying, what is the power that you have to take 3 in order to get 9? 3 to the second is 9, right? So that's what a logarithm is. What is a logarithm? A logarithm is like an exponent. A logarithm is like an exponent. Okay? Now, I think that's the first order of business is to acquaint yourself with this definition. Let me give you some examples to practice on. If I said log base b of x is equal to y, can you translate that for me? What does it say? b to the y equals x. Every time you see a problem involving a logarithm in section 1, now later we'll be doing some things with it, but every time you do something with a logarithm in section 1, you're going to be starting off with a base number raised to the power equals this. Yes?
Is the L of n the same way?
That's right. And when we get to it, the ln is a special type of logarithm. The ln is a special type of logarithm. That's right. Okay? Let's see, let me get some real estate here. I'd like to take a few examples of this from section 4.01 and see what kind of problems you're going to have to work with. I'd like to take as an example number 17. Log base 2 of the cube root of 2. Log base 2 of the cube root of 2. let's say we don't know what that is, which we don't. Does that look like a foreign language to you? What do you do when you've got something that's in a foreign language and you don't understand it? Logarithm. I don't understand logarithms. Find a translator, right? Translate it back into your own language and then figure out what it would have to be. Now, if you don't speak logarithmic, then let's change it over to exponential notation. In other words, let's let it equal what? X. Or Y, or whatever letter you want it to be. There's nothing special about X, except it's my favorite letter, I guess. Now what? Translate it into exponential notation, which would be what? Base number is 2. 2 raised to the x power equals to the cube root of 2. The cube root of 2. Now in order to answer the question of what is the power, 2 to a power. See that? 2 to a power. We've got to be able to write this as 2 to a power. And so far, if you don't know how to write that as 2 to the power, you can't answer this question. You have to be able to write it as 2 to a power. I don't mean 3 to a power or 4 to a power. You've got to do, if this is 2 to a power, you've got to get this to be 2 to the power. So what would it be? 2 to the 1/3 power. All right? 2 to the 1/3 power. Now, can you see, therefore, that the, let me get the right color here, x would have, if the base number is the same, if the base number is the same and they're equal, then the powers have to be equal, don't they? So what can you say here? X equals to 1/3. Okay? So x equals to 1/3. Any questions on that? All right, let's try another one that get a little more complicated than that. How about number 20? Number 20. Number 20, it says log base 2 of 2 cube root of 2. And again, we'll let it equal x. Okay? And you don't speak logarithmic, so you change it over to exponential notation. Okay, so what would that be? The base number would be 2. Right, there's 2. Raised to the x power equals to 2 times the square root of 2. 2 times the cube root of 2. Okay? Now what's the key base number here? 2? In other words, this is 2 to power. So what this one over here has to be is 2 to power, right? Now, do you know what 2 is as a power? It'll be a 1 power. In other words, that would be 2 to the 1 power, this one. And the cube root of 2, we just talked about that. That would be 2 to the 1/3 power. When you multiply, all right, you put down the base number first, by the way. What would that be? 2 to the power of 1 and 1/3. When you multiply, you add exponents, right? When you multiply, you add exponents, so that would be 4/3. Right? So we got 2 to the x. 2 to the x equals 2 to the 4/3. Same base number. They're equal. Therefore, what? X equals 4/3. So x equals 4/3. Is there any question on that? Okay. All right. Now, something different happens in number 24. In number 24, it says log base 27 of 9 is equal to x. Okay, now what would you do with that? Start with the base number, which is the 27, raised to the x power equals to 9. Okay? Now the problem is, these are different base numbers, aren't they? Before, what we had is 2 to a power, 2 to a power. And I said the only way we can do this is if it's 2 to the power, or if it's the same base number to the power. So Can you do something with 27? Is there something special about 27? It's a perfect power, isn't it? 27 is actually 3 to the third. And that's all raised to the x power, isn't it? Okay. Now what that equals is over here 9. Now 9 also is 3 to a power, isn't it? 9 would be 3 to the second power, 3 squared. Okay. Now this, when you raise a power to a power, what's the law? When you raise a power to a power, you multiply the exponents, right? So you put down the base number 3, and it's raised to the 3x power. Okay? And over on the other side, we've got 3 to the second power. So now, you see, we got 3 to a power equals 3 to a power. So what do you know about this? If the base numbers are the same, the exponents must be the same. So what can you write? 3x equals to 2. And therefore x equals to 2/3. Divide both sides by 3. Divide both sides by 3. And therefore x equals 2/3. Okay? X equals 2/3. Any questions on that? Okay? All right. Sometimes the x is not out at the end. Sometimes the x is the base number, is the unknown. Sometimes this number is the unknown, like number 28, for example. What I'm doing, I'm trying to take a sampling of problems from this section 4.01 and give you a variety of different kinds of problems. And I want to ask you something when I get done with all these things. I'm going to ask you, what was the difficult part of section 1? Was it logarithms, or was it something else? What was hard about section 4.01? That's what I'm going to ask. Keep that in mind. Number 28, as an example, it says log base 5 of x equals to -2. Log base 5 of x is equal to -2. So what do you have to do first? 5 raised to the -2 power is equal to x. Okay? 5 to the -2 power is equal to x. Does everybody know what 5 to the -2 power means? 1 over 25. 1 over 5 squared, which is 1 over 25. Can I just go ahead and do that? 1 over, it would be 1 over 5 squared is equal to x. And therefore, x equals 1/25. 1 over 25. Okay? Could you have used your calculator on that? Would that be a good place to use a calculator?
You would have gotten 24.
You'd have gotten a decimal, wouldn't you? Which is equivalent, okay? So it'd be fine to use a calculator on it. Go ahead and use the calculator to do 5. And then raise 2, that means, x to the y power function. -2 power, which means you probably input the 2 and then plus or minus key. And then execute. Does it come out to 0.04? Which is equivalent to 1/25. I would accept either of those answers. It doesn't? Uh-oh, must have done something wrong. It's supposed to come out to, try it again. Try 5. All right, keystrokes. 5 is the base number, then what?
Raised to
X to the y power or y to the x power, whatever your calculator says. Now you've got to give it the 4, the 2 probably next, don't you? You've got to give it the -2, but you may want to enter the 2 and then the plus or minus key. Okay? And then execute.
You get to base or minus first.
Maybe you have to enter the minus. In your case, it's probably the -2. Enter -2. Did you put parentheses around the -2? I don't know. Depends on the calculator. You shouldn't have to put parentheses around the -2, I wouldn't think. Still didn't work? Check with me after class. All right.
I know how to do it.
All right. Okay. Now, after 28, I'd like to take a look at 32. number 32, which says log base 9 of x is equal to 3/2. Oops. So long purple. Now what? 9 raised to the 3/2. 9 raised to the 3/2 is equal to x. Now the problem is calculating 9 raised to the 3/2 power. There are two ways to do this. One is with this calculator, the one between your ears. And what would that require? How do you do something to the 3/2 power?
Convert it into
Square root of 9 raised to the what? 3 power, which is equal to x, and that's easy to calculate. Square root of 9 is 3. 3 cubed is 27, right?
You can't just take 9 raised to parentheses 2 divided by 3.
That's right. That's the other way. The other way is to use the calculator in your hand. And that's to calculate that, going 9. Now, actually, you can do 3/2, can't you, in your head? 3/2, what's 3/2 in your head? 1.5? So you could do 9 raised to the 1.5 power. Try that. Try 9 raised to the 1.5 power. Does that give you 27? Yes?
Yeah.
Okay. Or if it's something you don't know, you could always do the 9 enter into the calculator and then raise to the 3 divided by 2 power. Go ahead and calculate that. You have different ways to do that with different calculators, of course. Another way to do this would be to take 9 cubed and then do the square root. Have you ever tried that? Try it. Try doing the square root of 9 cubed. You see how that's different from this? This says you do the 9 square root first and then raise to the 3rd power. This says you do 9 cubed, which is some huge number. Well, not huge. What is it? 729? 9 times 9 is 81, times 9 again would be 721. And then take the cube root of that. That might not be the best way to do it. If your calculator will allow you to take the cube root of 729, you get, guess what? 27. Okay? No, I'm sorry, the square root, not the cube root. I'm talking about square root. All right, do it. Do it. Give your calculator 929, and then do the square root. 729. 729, sorry. Erase all that on the table.
729, yeah.
Just kidding. We'll have to live with this, you know. Rapidly messed up.
Square root.
Okay, take 729 and then do the square root. And it comes out 27. Okay? All right.
A lot of ways to get there.
Okay. Okay. Let's see. I'd like to look at number 42. As a sample problem. It says log base b of 16 is equal to -2. So first thing is to translate it. What does it say when you translate it? b to the -2 equals 16. All right, now what do you have to do? You got b to the -2. You can rewrite that as what? 1 over b squared, which is equal to 16. Now, one thing that's unfriendly about this problem is you've got this fraction 1 over b squared. And I just want to use this as a means of showing you a shortcut for eliminating the fraction here. If we took the reciprocal of the left side, what's the reciprocal of 1 over b squared? In other words, invert the fraction, what would you get? You get b squared, right? You get b squared over 1. And what if you take the reciprocal of this side? You get 1/16. So in other words, I'm saying this is like 16 over, just take the reciprocal of both sides. It's a handy tool that we can use. In other words, what I'm saying is if two fractions are equal, then their reciprocals are also equal. Okay? So now b squared equals 1/16. What would b have to be? B would have to be 1/4. Now what happens when you take the square root of both
1/4
sides?
squared though, isn't it?
Well, it'd be the square root of 1/16, which would be, in other words, the thing I'm trying to get you to see is it's going to be plus or minus in there. Plus or minus the square root of 1/16, which is plus or minus 1/4. I just took the square root of both sides, like this. Okay? The square root of both sides. The square root of b squared would be b, and the square root of 1 is 1, and the square root of 16 is 4. You see that? So it's the square root of 1/16, which is 1/4. But the thing that is bothersome here is there's a plus or minus that enters. Anytime you take the square root of both sides, you have to put plus or minus in there. So does that mean there are two answers for this b? What is b? b is the base number. And it just occurred to me that I forgot to mention there are some restrictions on this definition of logarithms up here. You can't have a negative base. In other words, the base number has to be greater than 0. And it wouldn't make any sense to have a base number of 1, because 1 raised to any power would be 1, and you'd never get anywhere with that. So base number cannot equal 1. All right? Now, another restriction on this is this number. If you're taking the log of a number, this number right here cannot be negative. The number of which you take the logarithm must be greater than 0. I didn't want to get into that heavily right now. I just want to point out to you that the base number cannot be negative and the base number cannot be 1. And we'll pick up any other restrictions in a later explanation. Okay, so that's what I get. I get b, the value of this, b equals 1/4, because b has to be positive. The negative answer is rejected. Okay, let's take a look at one more problem. Let's look at number 60. Number 60, which says the log base b of 9 is equal to negative 2/3. Okay? Translate it for me. B, base number is b, raised to the negative 2/3 is equal to 9. Now you've got b raised to some power here, and we really want to get b raised to the first power, don't we? Wouldn't that be a nice goal to have b to the first power? If we get b to the first power, we know we've got something. So what I want to do here is I want to end up with b to the first power. In order to end up with b to the first power, what I'd like to do is raise both sides of the equation to some power. What power would you have to raise this to in order to get 1? You'd have to raise it to the negative
1/3.
3 halves. Negative 3 halves. That would give you, when you multiply the, remember when you raise a power to a power, you multiply the exponents? So in order to do that, it's going to have to be negative 3 halves power. That would give you b to the 1. So if you raise this side to the negative 3 halves, we'll raise the other side to the negative 3 halves power as well. That means take the 9 as the base number. 9, raise it to the negative 3 halves power, which you can do with a calculator or you can do it in your head. Whichever happens to be the easiest for you. I would negative 3 halves power. That's what we need to calculate. 9 to the negative 3 halves. What root? If you do it in your head, it would be a square root of 9 and then raised to the negative 3 power, right? Okay, now what? 3 to the negative 3. This would be 3 raised to the negative 3 power, and that would be 1 over 27. 1 over 27. Okay? Question?
So negative 1/37.
Now, a negative power means 1 over.
Okay.
Doesn't make the fraction negative, remember. Okay.
would .2311.
That'd do fine.
Is that the same as 127?
How would you know for sure? Use your calculator to get the value of 127. And I think you'll find that it does come out the same.
Is it b to the first equals 127 or is it?
Right, 127.
B to the first equals
Right.
127?
So that's the answer, 127. Okay? Now, of all that I've done so far, I just want to stop and ask you the question, what has been the real problem here? What has been the real problem? Logarithms or exponents? Exponents. I mean, I've been beating you to death with logarithms today. I've not been beating you to death with another one for the camera there. What I've been beating you to death with is not logarithms. We've been using a very simple little definition that you've got the definition down. I'm convinced everybody here knows the definition of logarithms. But what's hard about this is all the different things that you can do with the exponents. So let's get to one more problem on this section, number 68. And in 68, we can do it by hand or we can do it by calculator. And this is a lead-in to section 4.02. I want to take the log base 10 of 0.01. Okay? What would you do if you translated this first? 10 to the x equals 0.01. Well, that's the first time I've given you a decimal problem, right? So what would you do with 10 to the x equals 0.01? Does anybody know what 0.01 is?
1 over 100.
1 over 100, right? Do you recognize it now? 10 to the x, 10 to what power would be 1 over 100? Do you recognize what 100 is? 100 right here would be like 1 over 10 to the second, right? So I've got 10 to the x, 10 to the x equals 1 over 10 to the second. What do you have to do to get a fraction, to get 1 over something? Negative exponent. So therefore x equals what? This x right here would have to equal -2. -2. All right, now crank up your calculators and let's take another approach to this problem. You've got a button on your calculator. Actually, you've got two different buttons on your calculator. First of all, I want to talk about the log button. You have a button on your calculator that says log, and probably right above that it says 10 to the x. Is that what your calculator says, something to that effect? That means that your calculator, and by the way, log on the calculator means log base 10. I waited this long to give you a log base 10 problem, but now that I've done it, let's go after it with a calculator. All you have to do is give the calculator 0.01 and then take the log of that. Now, you've probably got two kinds of calculators. How many of you have graphics calculators? So I know who I'm dealing with here. Okay, about 3, 4, 5 of you. Okay. And how many of you have, the rest of you have regular calculators, the non-graphics calculators? Right, those of you that are doing the graphics calculators, you'll have to enter the log function first, and then enter 0.01, and then enter. And guess what you got? -2. The rest of us that have the other calculators will have to go 0.01, and then just hit that log button. And what do you get? -2. Is that right? In other words, that's all you have to do with a calculator to get the log of a number. I mean, man, when I was in school, we had to look it up in a table. And if it wasn't in the table, we had to figure the proportion of the way between the entries of the table. We had to work hard to get this stuff. And all you have to do is just push a button on a calculator. And so logarithms is really a lot easier than they were when Napier first devised this concept, believe me. All right? Now, on the next page, on the next section, I want to start talking about 402 right now. And in 4.02, there are two different major systems of logarithms in use today.